This is done through the add weighted function from OpenCV. And it's actually a really simple idea. It just uses both images and combines some sort of weight attached to each image or each image's pixel, adds them together, and that results in your new pixel. So the formula is essentially the following. The new pixel in the new blended image is equal to some value alpha of your choosing times the first pixel in the first image plus some value beta that you also decide times the second pixel in the second image at the same location. And then if you want, you can optionally add in a gamma factor. All you're doing here is you're doing a weighted sum. If you want pixel 1 from the first image to be more represented, you would just make a higher alpha value. If you want the image from pixel 2 or the second image to be less represented in the blended version, you would just lower your beta value. So all you need to do is just alpha and beta to your choosing, and you can have the image 1 show up stronger in the blended image or image 2 show up stronger. And if you want, you can also add in a gamma value to manipulate the image further for the blended image. Okay. So with that being said, we're going to explore the syntax for OpenCV in this lecture. It gets a little bit complicated when your images are not the same size. You have to do a little bit of masking, so we'll show you how to do that. We're going to start off with some simple examples where we just blend in and add and paste images together that are the same size, and then we'll do a more complex example where we actually have images of different sizes and then we blend them on top of each other. Let's get started. All right, here I am at a new notebook. I'm just going to import CV2. That's all we need for now. And let's open up the images that we're going to be working with. The first image is going to be the dog backpack image. We'll say CV2 image read, and depending on where your data folder is, you can go ahead and read it in. In my case, it's in the same directory as this notebook, so I'm going to read in dog backpack. And then image 2 is going to be cv2.imread, and in this one, we're going to go ahead and grab what's known as a watermark. So we'll say watermark no copy, and I'm actually then going to convert these to the right color, because remember CV2 reads them in as blue, green, red, and we actually want to read them in as red, green, blue. Which means right after these lines, we'll say image 1 is equal to cv2.cvtcolor, and we'll pass in image 1, and then, pass in image 1 and say cv2 and color, what we're going to say is underscore bgr to RGB. And we're going to essentially copy and paste this command and do the same thing for image 2. So just replace that 1 with a 2 there. Okay, so that loads them up and does the color correction. Let's do a quick showing of these. And if we want to show them, we first have to import matplotlib.pyplot as PLT. And we'll also do matplotlib inline for the Jupyter Notebook users. We'll say PLT imshow. And what we're going to do here is show the first one. So there it is. There's that cute dog in the backpack. And let's see the second one. Imshow image 2. And this is a do not copy. So something to note here is that these are actually not the same size. And you can see this right off the bat with the dimensions shown. The dog in the backpack is from 0 to around 1400 on the y-axis and 0 to probably around 800 on the x-axis. And then image 2 on the y-axis goes from 0 to a little over 1200 and then 0 to a little over 1200. And if we actually check the shapes themselves to get the exact dimensions, you can see here the shape of image 1, so these dimensions plus the 3 color channels, and then image 2, we can check the shape of that one, and again, it looks like it's almost square, but it's actually not, and then we have the 3 color channels. Let's start off by actually resizing these images so we can show you how you can directly paste images on top of each other and blend them together. So I will resize the images so that they are equal to each other, and let's resize them both to be 1200 by 1200. That will distort this dog backpack image, so keep that in mind. But for right now, we're going to go with the simple example of not having to create a mask, because often when you look these sort of things up online, they're conveniently the same size, and then they don't show you how to actually blend images together that are different sizes. So we're going to show you both. If they're the same size, it's a lot easier. If they're not the same size, it's a bit trickier. Let's start off with blending images that are the same size. We'll say blending images of the same size. Okay, so first thing I'm going to do is just resize them. We'll say image 1 is equal to CV2. Remember, we can resize images. And then we'll say 1200 by 1200. I'm going to copy and paste this command, and then just change it from image 1 to image 2. And that will resize the images. Now keep in mind, they're going to be slightly distorted now. So notice the dog backpack has been squeezed a little bit to these dimensions, as well as the do not copy, although it's much closer to the do not copy's original dimension, so it really doesn't look that squeezed. Now let's go ahead and blend the images using that image formula that we saw earlier. The way we do this is actually pretty simple. All we do is we say blended, or whatever variable you want to use. Blended is equal to CV2, and then we're going to use that add weighted function I mentioned. And the add weighted function, if you do Shift Tab here on Jupyter, it'll show you it takes source 1, that's the first image, plus some alpha value that you want to multiply source 1 by, then source 2, plus some beta value that you want to multiply it by, and then an optional gamma. Let's try it out. We're going to say that our source 1 image is the dog backpack image, so image 1, and we'll have that be alpha 0.5. Source 2 is going to be image number 2, and we'll have that beta value also be equal to 0.5. So essentially, we're going to see both images more or less the same amount. And I don't want anything else, so we'll say gamma is equal to 0. And you can play around with these values as you see fit. We'll say PLT imshow blended. And if you check out blended, we have equal amounts of representation from the dog in the backpack image as well as the do not copy image. Notice that the do not copy, it had white as a background, so you do see that white showing up on top of that dog backpack image, which is why the dog backpack looks a little more faded. Now let's imagine that we really wanted image 1 to shine a lot more. So we could give it a much higher alpha value and give image 2 a much lower beta value. And if you were to rerun this, you'll notice now you can barely see the do not copy on top of the original image. So that's how you can manipulate the actual blending through the alpha and beta values. And then you can also experiment with the gamma and see if that affects anything. Oftentimes the really most important parts are the alpha and beta. Okay, so now let's go ahead and show you how you can overlay images of different sizes. So far, we've been lucky these two images were the same size. If you try to do this exact same process with images that are different sizes, you end up getting an error. So we're going to show you two operations. The first operation we're going to show is how can you make it appear to overlay a small image on top of a larger image. And this is going to be with no blending. So no blending. And all this is actually going to be, it's essentially going to be a NumPy reassignment operation. So we're just going to take the values of the larger image and reassign them to equal the smaller image in a particular section of the larger image. So we're going to work through that one. And then the second one we're going to show you is how you can blend together images of different sizes. Essentially the same thing as we're going to do here, except we will be blending the images together. So in this first one, we're going to do a straight up overlay. You won't see the original image underneath. And then the second one will actually blend them together. But unfortunately, when you're blending them together, you can no longer use this add weighted. So this add weighted only works when the images are the same size. It's a little bit more complicated if your images are different sizes. Let's start off with the simpler, overlaying small image on top of a larger image. Okay, in order to make sure this works, I'm going to reload the images. So we'll come up here, I'm going to copy and paste these 4 lines of code that loaded the images. I'm going to run that, and let's take image 2, that's the smaller, that's the watermark, no copy, and I'm going to resize it to be a lot smaller. So let's make it 600 by 600. We'll say image 2 is equal to CV2 resize. I'll take that image 2 and then I will resize it to 600 by 600. Okay, so let's check out what that looks like now. I'll say imshow on image 2, and notice now its dimensions only go from 600 to 600. And if I take a look at the dog backpack image, which is now image 1, that goes from 0 all the way to 1400 on the y-axis and 0 all the way to around 800 something on the x-axis. So I can easily fit the 600 by 600 do not copy somewhere onto this larger image. And it's a lot easier to keep track of the images if you label one large image and another one small image. Let's do that now. I will say large image is equal to image 1, that's the dog backpack image, and small image is equal to image 2. That is the resized do not copy. And then what I need to do is figure out the actual logic of taking a chunk of the larger image pixel values and replacing them with the entirety of this smaller image. And it's actually pretty straightforward if you feel comfortable with NumPy slicing. So all you need to do is say X offset and Y offset. This is going to stand as your markers of where you actually start the image and where you're actually going to overlay the image. In this case, we'll start at the top left corner. So I will set my X and Y offset to 0. And then later on, we'll play around with these values. But basically what that means is I intend to paste this do not copy image over here at 0, 0. So X equals 0 and Y equals 0, that's the top left corner. So that will be my X offset and my Y offset. Then I need to figure out where I'm going to end my X slice and where I'm going to end my Y slice. Keep in mind, we usually don't make all these variables. You just do this as a simple command, but I think it's a little helpful in the explanations if you actually provide the variable names. So we have our X offset and our Y offset. How are we going to define X end? Well, X end is essentially your offset plus the length of X in the smaller image. So all we need to do is say X offset plus the length of X in the small image, which in our case is going to be equal to the actual columns. So that's the second or index 1 of the small image shape. So we'll take the small image, grab its shape, which remember returns a tuple. So if we check this out, we run this. So along the X, that's actually this number right here, 600. So we're going to say grab that one. And it's a really similar logical process for Y end. It's just your offset plus how tall your small image is. And your small image, how tall it is just equal to shape 0. Okay, so we're going to run that, and now we have X end and Y end. And then all we need to do is say, take the large image, and you're going to grab some chunk of X and then some chunk of Y, and reassign it to be equal to the small image. And it's a little backwards the way you have to think about it because of the way NumPy is thinking about X and Y versus the way your image is thinking about X and Y. So notice NumPy thinks of these columns as the X-axis here. And these Y values, those are essentially NumPy rows. So keep in mind, it gets a little tricky thinking about which one comes first, the X or the Y. So in this case, when we're saying large image, it should be from the Y offset first, sliced all the way to Y end, comma, the X offset sliced all the way to the X end. Let's run that. And now if I check out what my large image looks like, I have successfully overlaid the do not copy starting at this point 0, 0. So again, all we're really doing here is just measuring out a chunk of the larger image that happens to have the exact same dimensions as the small image. And then we're just replacing out those values. Notice here there is no blending. All we're doing is we're grabbing a chunk of the original large image and then replacing it with the smaller image. It's as simple as that. And we can do that with simple NumPy. You don't have to do all these in-between variable steps. You could have just put this all in one giant one-liner, but for explanatory purposes, I think it's a little easier to see out the variables. In your actual notebook, we don't take this extra step of Xn and Yn. We just stick those out into this large image reassignment. Okay, so that's how you can overlay images of different sizes, essentially just swapping out original information. Now what we're going to do is show you in the next lecture how to blend images of different sizes. We'll see you there and continue right where we left off.